one. This doesn't do anything with the, no. Yeah, the switch to ++I is because it's the simpler type. It's the one that returns the same value that it computes. Instead of the weird, it updates the thing but returns the old value. So I decided it was bad to be using I++ as the default everywhere. So I switched to ++I. And I don't regret it. It's just nobody else did, or nobody except Avasor. Any real practical effect? I mean, it just means it's one less thing to worry about when you see it. I also just like it because I think I prefer prefix operation in general. You know, it's a little bit like the whole function notation is foo of x. It's not x. I prefer to have the matrices on the left when multiplying matrices vectors, just sort of the matrix is applying an operation to them. I kind of prefer that the unary operators are on the left. And only use the plus or minus if you actually need crazy submit. But yeah, I mean, does it really matter? No. Just one last thing. I have no idea. Okay, so let me just count see what all the mallocs are here. Generate chunk. Generate chunk creates a gen chunk, and this creates a mesh chunk, right? And it doesn't free the MC if this fails. Oh wait, I don't store the MC. Oh, I see, it's in out mesh. But I never hit this code, so this isn't the problem. Mallocs. Generate chunk. That's it. Those are the only mallocs. Generate chunk and the 3 mallocs in here. So if I'm leaking memory, I mean, I guess maybe this is a lot of meshes. Yeah, I'm not worried about it from the optimizer. And what was that one I just added? Built mesh. That's a lot. Okay, so somebody is expanding. How can that be that big? No, we don't use any stack analysis. Jeff used to use lint back many years ago, but he got tired of it. And I tried to use lint when I heard that he was doing it. Back before I was at Red, I tried to use lint, but adding it to an existing project that hadn't worked. Okay, so this is clearly the problem. And this is back to that thing I was saying where the tail of built meshes had gotten updated and I don't know how. Oh, no, wait. I added the tail. No, I added the head. That's the only thing that add there, remove there, and nobody calls get next built mesh. Oh. Oh, I actually added this code already and forgot I had added it. Okay. That would be a problem. So I'm uploading meshes, but I'm never updating that I uploaded them. So this code doesn't know about it. Or something. so here we got a mesh built. Go in and we upload it. We never add it to the mesh cache. Problem. Whose job is it to do that? Should that be done here? Or should that be done here? Okay, that's the old one. Get mesh chunk for coord. Used in this file. Nobody uses this. Okay, from the beginning. Gets initialized. The single-threaded version gets initialized. Okay, so nobody uses it. And in this file, drive the request, check if it's available. Okay, so what we need to do is update it. So where was the function that updated it here? What does it do? It just calls upload. It doesn't do anything else. Because the mesh chunk is part of the mesh slot. Okay, so void set mesh chunk for coord in x and y mesh chunk. Let's see. So if MC bbuff free mesh chunk of MC. Otherwise, MC equals new MC. And I think we have to free new MC. Allocated it somewhere else. Mesh chunk MC. So we have to free it. And data. And board. Set mesh chunk for coord. Even actually, oh, we do. It's in bm.mc arrow at chunk x, bm.mc arrow chunk y, bm.mc coordinate. X equal. Oh, I'm in the wrong file. Do you ever set them? Or do I set that they're the right chunk? Does this single-threaded code work? Generate mesh for chunks accurate? Yes, it says the chunks. Okay. So let's do times chunk mesh chunk size x. Let's do times mesh chunk size y. All right. Okay. Well, it's kind of the right data, and then some other wrong data. I'm sure this will be trivial to debug. Why don't I use comments? Because when I'm streaming, I'm worse about typing comments. That's why. And to say things out loud instead of typing them. So I'll have to go through and make a lot more comments in code. So I'm continuing to fly because I want to see how stable this code is. At least it was fast because it's all in the background now. You can't tell, I guess, because grid speed, but I'm just locked at 60 frames per second. Oh, there we go. Oh, and I was hitting spacebar to move upward and didn't see them. Good job, me. It would be nice if it didn't have the auto repeat, that I'm holding down space, that didn't make the auto repeat trigger and detect it as a. And now I have to run again. No, I don't do any of that kind of stuff for the chunks. I'm currently not even paying attention to the orientation of the camera. Because I want you to be able to, in the long run, you should be able to snap. There we go. I like how everything's still running. The assertions in this thing don't bother breaking the other threads. So it died in one of the background threads, but happy to keep rendering. So, Assert GC, with malloc failure. So something's still leaking, or something else is going wrong. What is happening with the floating things? That is a very good question. That is just got this code running for the first time. And does not work correctly. But it almost works. So yeah, that's a very good question. How would you even get that kind of wrongness? Like, are these multiple meshes at the same location, or is it part of that mesh is bad? Is it getting bad chunk data for some of the chunks, but not all of the chunks? Right, because remember, each mesh chunk is 2 by 2 world chunks. I mean, obviously where there's a hole like this, okay, it's just had bad data for this mesh. But it seems like some of the good meshes also have, yeah. Like here's this is some extra data at the top above a good mesh. Of course, a lot of this data is at the same height, which is suspicious. You also have spikes going up. There are multiple heights that they're at. All sorts of possibilities. It'll run out of memory. Yeah. So but anyway, so yeah, no, I don't even take orientation account currently for the priority. If there's a priority function, it computes in one place, and if I want to make it start doing stuff like that, I can. However, in the steady state, I expect you to have built all of the world around you. So there are two things. I don't account for orientation because I want you to be able to mouse look around instantly and have the stuff behind you already be loaded. So I still want to load that with pretty high priority. I could prioritize, you know, sort of weighted priority. The stuff in front of you is still more important than the stuff behind you. If you haven't got the stuff in front of you yet, you probably should do that. And I could do an orientation thing where or a velocity thing where while you're moving things are favored. However, in the steady state, what should happen is all of the stuff immediately around you is loaded, and it's only stuff that you can't even see out on the horizon being loaded. And in that steady state, your velocity doesn't really matter. You just want to load the entire circle around you. And in fact, if you've been moving, you're coming from some direction. So the circle behind you that you're not coming from has already been computed and is already there in the cache. So there'll just be a 180-degree chunk of a ring at the far view distance that needs to get graded, and it doesn't really matter what order that stuff gets built because it should be fast enough. I mean, in general, this program, you can always set the view distance out far enough that it can't keep up, and then those kind of things might matter. But that kind of priority heuristic-y thing, A, you can go fix it at any time because it's just an isolated, a single expression. And B, those tend to just have unexpected consequences. It tends to be safer to do simple things. Like what that reminds me of, it's totally unrelated, but a lot of people who do LOD or other kinds of calculations based on something to do with the camera, like the screen space info, like where it is on the screen or something, you know, how close it is to the frustum or anything like that, leads to a system that, compared to a system where you only compute that stuff based on the camera position and not the orientation, those things have this problem that as you look around, things can shift and change. Whereas if you only compute them based on the camera position, then if you're sitting in place and looking around, everything is rock solid and stable. Like I said, that's not the same thing. I'm just saying it's sort of a similar thing where it's like people imagine that it's a good idea to use these more sophisticated heuristics, and they actually can have drawbacks, and you're actually better off just using the depth fog is a classic one where depth fog is based on the z depth and is the standard OpenGL fog, I think, and is not actually right. As you turn, you'll see things move in and out of the fog based on where they are on the screen. When they get to the edge, they're more fog, less fogged, which is just wrong and dumb. VC6 is a pain to get working. I actually had to hex edit part of the installer because it would refuse to get past a certain thing. It might not have been a hex edit. It might actually have been a text file. I don't remember now. But you had to change 1 byte of it. And there were instructions on the net for how to do it. And I did it many years ago. And then I just keep that copy of that installer around. I think that was to make it work in Vista was required. So I just keep that copy of the installer around and always install from that. So most likely what's happening is I'm getting the wrong chunk data. The question is, how could I get the wrong chunk data? So how could I get the wrong chunk data? Well, I could have ref count failures. I could have memory overwrites, seems pretty unlikely. I could have some kind of thread problem where the threads think it's done, but it's not done. But since I use that whole manager task, it seems unlikely. All right, well, let's just have only one mesh worker and see what that does. They're not really mesh workers, they're mesh gen workers. Aha. So if I only have one worker thread, everything is fine. See, now now let's do something where have one thread devoted to one thread for each task. Oh, I don't have any good way to do that because they use a single semaphore signal. Well, let's just see what happens when we have two tasks. Look, get errors. So most likely, either one of them is freeing the gen chunk before it's finished using them, or one is trying to build the mesh before the gen chunk has been set. But the latter case, it should get a null gen chunk, which would crash. So the fact it doesn't crash makes it seem more likely that it's just accessing old invalid memory or something. Yeah, the threads shouldn't be writing to them simultaneously because the threads malloc the chunk data. So only one thread should have access to it until it's finished creating it. And then once it's finished creating it, it writes it. Where does it write? It writes it to a queue back to the manager. Let's look at that flow. So generate terrain, generate it, boom. Once we generate it, we put it in finish gen. That fails, we abandon it. Let's make sure that's never failing. Yep, okay, things are going wrong and it has not failed. Then we wake it up, and it wakes up and it walks through the generated chunks, and it calls end procgen before it does anything else, which is just updating the cache of that we had one of those, so that it knows. That's because we're putting in the main cache now. And we put in the main cache. Not fail. Chunk. Yeah, I bet that could fail. If that could fail, no, it can free the existing. It's called free gen chunk, not release gen chunk. Is that correct? Yes. It increments the reference count. Okay. So that increments the reference count, and then we release the copy that we had for the queue. Actually increment it before, as we were putting in the queue. Yes, we added to the queue, we incremented the ref count. Now we put in the cache, that increments the ref counts, release it because it's not in the queue anymore. Okay, then now it's in the cache. So somewhere we're going to try to get it out of the cache. Here, cache for chord. If we find it, set that, and we add a ref count to it. Now that should stay true forever until we create it. That copy should live there in CS chunk. Should not be able to change. Yeah, well, Minecraft is already running like this in my KView app that I released on April 1st. But I didn't release it as an executable, instead as source. Because it's not really full Minecraft. Feel like to have an expectation of it being actually a full Minecraft. How could this chunk go wrong? And then eventually down here we have valid chunks, we get the chunk status, is the thing that contains the chunk, pointers to the chunks. Pop that into here. Let's go into processing. Zero out all the chunk data because now it lives in the task. And since we copied it, the ref count should not here. Check my chunk has been generated incorrectly, and maybe. I mean, I don't think it's being generated incorrectly. I could detect when the mesh sees a wrong chunk because there's data outside the range that I know the current generator does. But working backwards from there is very hard because that's all indirected through queues and asynchronous across threads. So really have to figure out it's not even clear like when, like that's sort of what I'm trying to do right now is figure out how it can even go wrong so I can decide where to look to find it going wrong. Trace back from. Because I know it's too late to check it at the mesh generator, because at that point it's at the wrong end of a queue. The possibility would be just that I have some kind of bug with something. So let's just, I thought about doing this assert before. I just want to, I don't think it's possible because this is exactly what I looped. I can't use sign. Oh, I can't use sign. They're weird, but whatever. Assert MCS chunk set valid of JOI just to be on the safe side. Oh, okay. I mean, I'm fairly certain that the chunk itself isn't created wrong, so I can't catch it there. The problem is that somehow, somewhere in the process, I either end up with a bad chunk pointer or it gets freed out from under. But since the ref count is locked, I mean, I guess I could have a ref counting bug that only triggers with more than one thread, though. It seems a little unlikely, but I guess it's possible. Yeah, I don't see how that could be wrong. Yeah, anyone you ask is going to prefer the languages that they happen to use, and they're not really going to have an opinion about what the best language for you to start with is. It's certainly true, it doesn't really matter what language you use. It's the skills you learn are generally applicable to all languages. Most of the skills you learn. So it usually starts with what is it that you're interested in doing, and then what do people who do that sort of thing normally use for a language? Probably. I just don't even know what to look at here. Hate threading. We're at black and slick. Let's see, what could you do? You want to see when the chunk set claims to have a chunk but is invalid. Let's see what triggers that. So how can you tell that? You can iterate through void check chunk sets void. So you iterate through all the mesh statuses. How many are there? Mesh chunk cache. Oh, but they're not. They can be outside of this now. They don't have to be in this. That's one of the whole things that what the threading can do is it can overwrite them. All right. Well, maybe it's not. Maybe it's still in the mesh. Chunk status. Mesh chunk status MCS equals mesh. What is it? Status of J of I. If MCS status equals chunk set. Say another thread could change this out from under while we're testing it. Just hope that doesn't happen while we're debugging. Yeah, if somebody reposts the YouTube, there it is. I'll put it in right now. As long as I'm brain dead, stuck on this. Correct. Yep, looks like I got that in there. All right. I'm live on Twitch. Start watching. Oh, that's interesting. Didn't actually tell it to do that, but whatever. So what was I doing? I'm creating this data, I'm searching this data structure. If the status is chunk status non-empty chunk set, then for n equals 0 and less than 4, for m equals 0, m less than 4, if yes chunk set valid of n of m, validate yes chunk gs chunk of n m. So now the question is, how do we validate? Yeah, whatever, I'll leave it. Void validate mesh chunk. For I equals 0, I less than mesh chunk size x times mesh chunk size y. Assert chunk. Not chunk. I don't want a mesh chunk. I want a gen chunk. Chunk arrow partial 0 dot block of 0 of I does not equal 0. Assert 8. I don't actually know what my max size is, but size 10. If these die immediately, well, there's something wrong. Check chunk sets. Nope, did not catch it. Okay, then validate the gen chunk. In here, validate .cs chunk of 1. If this catches it. Yep. Okay, that's not catching it. So how high am I? $246. So it is going all the way up to the top. And I'm checking some like sort of middling data. So let's validate that. Check near the top. Oh wait, I said does not equal 0. It should say equal 0. Of course, how that would ever, that would imply this isn't checking the right. Oh, because I'm not also doing this segment. Wait, how come this doesn't, oh, that's just a pointer. This wasn't even checking anything, it was checking a pointer. The segment size? What's it called? Segment size. 16384. So 16384 over 16. Oh, I'm wrong. Okay, that doesn't catch anything. Even as I'm generating them, it doesn't catch it. Doesn't make any. Oh, I know what the bug is. Ha ha ha. Yeah, it's nothing to do with any of this. It's a bug that I noticed at one point and never did anything about. Face buffer. Not face buffer. Yeah, okay. Face buffer. I said I needed one of these per thread. Which also means I need to make them a little smaller because that's too big. So type def struct date vertex build buffer date face buffer thread data. Work with threads. Data td vertex build buffer equals malloc 16 times 10 24 times 10 24 data face buffer. How much does that make room for? That makes room for 1,000,000 vertices, which is 256,000 quads. That make quads, and over 64 over 64. That allows for about 64 quads per column, which isn't that high. You don't really want to waste a lot of memory if you have a lot of threads. You have 16 threads. This would use 256 megs currently. Use a lot more if I doubled it. So we'll go with that for now. And we'll let it crash or produce bogus data rather. Okay, so then I still have to actually make the mesh maker permanent. So generate mesh for chunk set. Now it needs to know about these new sizes. And I still actually need these static ones for the single. Oh, except it's passing them in. Oh, okay, yeah. Chunk set. So here's the old one, and this uses size of, right? Okay. And the new one, not going to use those. It's going to use td.vertex build buffer, td.face buffer, and size t for off size equal off size. I mean, I don't know for sure that this was the bug, but this was a bug. I don't really know how this would produce that behavior, but who knows? It might be the same thing. Like, do we assemble this data? I think I might be doing it in the assembly. Yes, the segment block type stuff. This is the one where it would make sense that that would cause problems. it's trying to build two meshes at the same time, and it's reusing the same data structure, and it's reusing them at different heights at the same time, because this is only building 16 rows at vertical slices at a time. So that would be the one that actually is causing the bug, but we need to do it for both. So now this is vert buff size. And so this thread data also needs thread data. Put this down. Doesn't even really need to be a struct. These could just actually all be local variables, I guess. Oh, except what I want to do is pass it in. Build data. So then we want to have .8 segment block type 66618 and 8 segment lighting 666618. Data BD and segment block type. Data BD. I think I actually am capping. I have a max worker threads that I can use to cap it and worry about the memory, but I want this to be a little bit future proof. So, you know, and I don't actually know how many people have 8 threads. I'd have to look at the Steam hardware survey or something. What's the error here? I don't have build data defined yet. No, I'm pretty sure the segment block type stuff is the bug. It would produce that exact behavior. I'm pretty sure. Oh, build data is defined now. Oh, it's not up here. All right, and then we have to build data vertex build buffer. BD. Now this is 6 times 60 times 18 times 2. How big the segment data? 150K, so yeah, I don't want Octathon on the stack, so I'm going to also have to do something else. Copy chunks to that, needs to pass D. Yeah, and this doesn't use all of your cores. This, if you have a large number, it only uses half. So to get to 16, you would have to actually have 32 hardware threads, according to the way the current code is currently set up. Whether that will stay, I don't know. BD. Static build data. Static build data. Static build data. Face buffer equals face buffer. Static build data dot vertex build buffer equals vertex build buffer. And let's just leave this one. Build data BD. It's malloc size of star BD. BD vertex buffer. Face buffer. BD. Okay, and now it doesn't build anything. Is that because of something I changed? No, this was definitely running a second. Okay, then I generate the vertex build data and then I copy out of it. Where do I do the copy out? Here's where I copy out. Copy out of the wrong thing. And single threaded case. It's doing the right thing. All right. Now I'm 60 frames per second, even though I'm in a debug build. And it looks like it's working. It might still be leaking memory. We might still crash eventually. I still don't have any code, you might recall, to clear out the cache of old data. It will eventually start reusing the same slots of the cache to get rid of the old data once I move far enough, but also needs to kind of hard limit. So now you can see it's popping in. The question is, will I eventually catch up and we'll actually see it? Not them, instead of them all popping in at once, you'll see them building. And yep, okay, there. Now I'm moving fast enough that we see popping in. And the pop in, if I adjust the fog, will hide it. So I'm moving faster than it can manage to build in debug. But that basically seems to work. And it's out of memory. So something is still leaking. Yeah. But let's go ahead and build it and release and run it. I can outrun if my max movement speed. Oh yeah, I still have to switch that one also. See if the max movement speed, if it outruns the generation or not. All right, I don't need any more, so now we. So if they all pop in at once, that means I've moved far enough that a new set of chunks is being drawn. If they don't all pop in at once, that means it's having to actually build. And they're, oh. Eventually I'll update the stats so it'll show us how many are getting built. Then it'll be clearer. Yeah, this seems like it's keeping up. Not able to outrun the building. So let's push the view distance out. View dist. And now it has to build a lot more. Like 50% more. Now it's actually getting to the right distance so that things actually disappear into the fog. The fog is actually the right distance. We won't see any popping, or it'll run out of memory. Okay, I'm gonna have to fix that memory leak. But go ahead and git commit threaded procgen and mesh building. I'll go ahead and push it. If anybody wants to port this to another VC, you know, it should be trivial. I'll be happy to integrate that into the code base. I mean, I have other VC6s on this machine. I mean, other Visual Studios on this machine. I can do the work. I'm pretty lazy, so eventually I'll do it. But if anybody out there is actually trying to build this themselves and has already done the work to upgrade the Visual Studio project to a new version, I'm happy to fold it back in. I already set it up so there's a separate tree for just the VC6 project, so we can have another folder with the other VC. Okay, so this is done. So let's bring up the task list. So threaded building. Procgen and meshing. All right. So actually that was a lot easier to debug than I expected. It took me a long time to figure out what was going wrong there, but it was actually a thing I had already known I needed to fix. I just had failed to write it down, so I didn't. And so it took me a long time to figure out that that was the failure, but trivial fix once I remembered the thing. And since I had identified it in advance, I kind of count that as like, if I just bothered to write it down, it's been a big deal. So I'm kind of surprised. Until we get stats in, I don't really know how that system is behaving. It may still be doing dumb things behind the scenes. The Minecraft one has a problem that you set the max amount of data you want, mesh data you want. And when it hits that limit, it wants to build new things. And when it wants to build a new thing, it has to free an old thing. So it's constantly freeing an old thing so it can create a new thing. But the problem is it doesn't actually know. I don't have the data structures I built for this one. So it sits there freeing something and then creating the exact same thing over and over again. When you're in the steady state, it doesn't realize it doesn't need to. It just sits there churning, just a dumb thing because I didn't have the information available to know that, to know which things are getting created, to know whether freeing a given thing is actually a higher priority or lower. So hopefully the new stuff will have the information I need so that I can set a max and it will be well behaved, but that's for the future. How much work would it be to get to build 64-bit? Should be very little work unless stb.h. I think stb.h has had problems with 64-bitness. The thing to do for that is to just kill the parts of stb.h that cause problems. I think it actually, stb.h works, compiles in 64-bit, but the problem is the certain pieces of code in it that don't work. I have a malloc implementation in there that I just need to kill, and the string dictionary hash table actually uses that malloc internally, and so that always dies on 60. And then the rest of this code here should be pretty 64-bit compatible. I disciplined myself many years ago to write cross-platform code. All the types are wrapped in this. Would expect it to be pretty good. But I mean, I haven't actually been particularly careful. Well, of course, one of the advantages of this whole thing is that Minecraft has a view limit of 256, except in the 64-bit builds. And the 64-bit builds, you can actually bump the 512. And of course, the whole thing with mine is that in KView has a 1280 view radius, and it's running in 32-bit, no problem. I did not run into any scenes where it actually hit that my 800 meg or whatever my limit was, my 800 meg mesh limit. I mean, it doesn't do everything Minecraft does, and there are certain things that the compact vertex format that I can't do some of the things that Minecraft does. You have to actually use a different vertex format that wouldn't be as small, so, but it's just kind of amusing. So what did I want to do? I wanted to go to a do list. Thread mesh building, thread terrain generation. Limit mesh cache to max size. I was just talking about that. Check for memory leaks. Hey, look, that's our #1 priority because right now we are leaking memory, I think. No inline admin stb.h. There should not be any. stb.h was meant to be portable. It's got like a portable threading abstraction and a portable reader abstraction that have never been ported to other platforms that only work in Windows. But the intent was there, and so it should have it should avoid things like inline assembly. I believe there is like one inline assembly thing, which is the compiler read-write barrier, which for VC6 can only be done in assembly, but should have the appropriate if-defs so that it only uses that for VC6, the inline assembly, and for others it calls whatever the interlocked. I don't remember what the function is that you call for the eventually it's called read. But the main thing is I'm not using any of the identity from IH. I'm using the SDL threads and stuff, so we can trim stb.h down if there are problems, but I don't think there will be. I'll find. Other people have reported this problem with the string dictionary, which is why they must be successfully compiling stb. Maybe they had to modify it and didn't submit the modifications. Possible. But anyway, all right. So I've been streaming for 3 hours, so I'm going to wrap up. That's good progress. Got that stuff working. It's not very interesting stuff. It just got us back to where we were, except a lot faster. I never talked. I said I was going to talk once the Handmade Hero stream ended, that I was going to talk about what the plan was, and I never actually did that. So I'll go ahead and establish that now, because somebody was asking me, or Fabian was asking me about why I was doing this now. And it's a valid question in the sense of kind of a premature optimization question. It's like, why is making that stuff fast the highest priority? And there's a couple things. One is that I am a premature optimization person. Another is that, if it's optimization that you are going to have to do eventually, then the premature optimization, not the same negative downside. You really are going to have to do it eventually. And I knew I was going to have to do it because I had to do it for Minecraft to make the Minecraft stuff fast enough. Very aggressively. Well, it's the same math, so on my machine, it's 4 threads on Minecraft to build data. And I have an 4-core 8-thread hyperthread. But also it's because, for example, if you want to work on the terrain generation, it's really nice to have the terrain filled in fast so you can see it. And so background loading is useful because it makes the motion feel good, because otherwise it was running at 10 frames per second, jittery between 5 and 20 frames per second as it was using the rendering thread data. So it makes the movement smooth, which like good for morale, feels good. And then it actually can build in much quicker, 4 times faster with threads, or actually more than 4 times faster with 4 threads. The whole thing is that it was only building 1 thing per frame when it was using the renderer thread. So now it can use full CPUs for the other cores. It builds, so I'll have to put in those stats, 30 meshes a frame. So when you're iterating on the procedural generator, it's obviously going to be useful have very fast feedback about what it's doing. So, and this lets you, because it's across multiple threads, it lets it be sort of optimized for free. Like, in other words, if I write a not very optimal generator, it's still running 4 times faster than it would single threaded. And so I can be suboptimal with it and still get the data out of it, see what it's doing, without having to try to optimize the generator. In the long run, obviously, you optimize the generator, but while you're experimenting and figuring out, you often do things. Even the current one is very inefficient because I am calling Perlin noise 8 times per column or something like that, and the Perlin noise code is actually recomputing the same data over and over again within a chunk, with minor variations, and that can actually all be optimized and have this optimized mesh building task, or optimized train rather. And I did some of that. I did the easy stuff, but I didn't touch stuff like that Perlin noise. You don't really want to touch that kind of stuff until it's fun. So that was why I went ahead and did that. There's all those different reasons why. And the other is just that I had this list of things and I wanted to check things off this list, and why not check that one off, because it does feed into the other ones. You know, and some of these have dependencies. Like, so user block create destroy, that'll be interesting to do. Because now we have to rebuild the meshes on the fly, and of course the meshes are currently 64 by 64 by 255, and so is that too expensive to have to rebuild that every time? I think what we're seeing is that it's very fast to rebuild the meshes, so that'll actually be fine to just build the full mesh. Sitting there, like imagine we're Minecraft style, and you're sitting there hitting blocks, you know, or placing blocks, and you're, you know, placing 5 blocks a second, so we'll be recreating the mesh 5 times per second. Kind of inefficient. You can imagine strategies to do better where, you know, like currently it's a 64 by 64 by 255 mesh, but I could do a thing where it's like, well, if you start rebuilding, if you start creating or destroying in that, I'm going to assume you're going to keep doing that for a while. So let's split that up. Instead of being 64 by 64 by 255, let's make a 16 by 16 by 64 mesh, a grid of, you know, cube grid of them. And most of those won't change now, and now I'll only need to rebuild a little 16 by 16 by 64 at a time. That would let you much more quickly do stuff like building and destroying blocks. But my guess is currently that it's fast enough that that won't be necessary. But anyway, to do that, like a nice UI for that is that, you know, you're looking at a thing and you say place the block there, or destroy it. That's how Minecraft works. And so for that you need a raycast. So we'd have to implement raycasting first. And the raycast needs a physics representation. Physics representation, which we have to think about how to do the memory management for that, because you can't do the dense thing. I did the math, even if it's just 1 bit per block, if you wanted to do a very large map, you know, you were trying to keep track of the data around everyone. You don't want to recall the procedural generator, so you actually have to store that data. Currently, I don't store, right? I build these procedural chunks, they're these dense 3D meshes, 3D grids. And I build the mesh from them, and I just keep the mesh around, and the mesh is compact, and it only represents the surface, and it's only on the GPU. I don't even have that data anymore, and I throw away the procedurally generated data. So what I want to do is cache some kind of info about the procedurally generated data that I can use for physics. And currently, that procedurally generated data is 3 bytes per voxel. Physics wants to be like 1 bit per voxel, or a couple bits per. But problem with that is, even with only 1 bit instead of 3 bytes, if you want to never go and generate the train again, you have to, or not never, because obviously there's limits, but you know, you want, creatures are moving around, you want to cover a large distance, that's just going to use a bunch. So some thought has to go into that, and there are dependencies on that. So the point of all this was why I was doing the threading. It's just, you know, some of these have those dependencies and they'll take a while to get going. I really remember what. I just need to check things off the list, and that different things have dependencies, and it's can't do things that have dependencies that haven't been met yet. But you also, it's more valuable to do things that other things do depend on. because that opens up more possibilities. And although it wasn't explicitly listed as a dependency, it was this big advantage. Like I was saying, it helps with. So that's why I felt it was. So that was. I just wanted to explain that at the beginning, why I was doing this, and so I explained it now that I've already done it. All right, so that's it for the stream, and I'll look at chat for a little bit after I shut down the stream. So again, for watching. So now that I got this done, one of the things is I've felt obligated to stream debugging this because I've been talking about how hard this was going to be to debug, and so I felt like I couldn't work on it without streaming. And henceforth, I may or may not work on this stuff outside the stream. I don't really mind streaming, but if I want to work at it late at night or early in the morning, you know, at 5 a.m. or something, I don't really want to be talking, so I don't know that I'll bother streaming. So it's possible that stuff will get done in this program that will not be streamed, but I don't know for sure. And I don't know how often I'm going to work on it. As I said before, maybe there's going to be a once a month kind of thing. Here it was just I had this in progress task and I really wanted to get it done. We'll see. All right, so thanks for watching. Bye-bye.